Hello everybody, getting ready to do lesson 7.1 of pre-calculus math today, systems of equations. In today's lesson you got 10 points here on your notebook. So have your notebook sheets out or have your notebooks out, students. And then we got 44 points here of classwork to do today. Part 1, solving systems of equations, and this is for chapter 7, linear systems and matrices. So we're going to go right into a notebook entry here, students. Have your notebooks out. The methods of substitution and graphing. So far in this text, most problems have involved either a function of one variable or a single equation and two variables. However, many problems in science, business, and engineering involve two or more equations and two or more variables. To solve such problems, you need to find solutions of systems of equations. Here is an example of a system of two equations and two unknowns, x and y. So here we have this 2x plus y equals 5. This would be called equation 1, and then 3x minus 2y equals 4 would be called equation 2. A solution of this system is an ordered pair that satisfies each equation in the system. Finding the set of all such solutions is called solving the system of equations. For instance, the ordered pair 2, 1 is a solution of this system. To check this, you can substitute 2 for x and 1 for y in each equation. Check 2, 1 in equation 1. So here's our check for equation 1. 2 times 2 plus 1, does that equal 5? It does, so it checks. And then check 2, 1 in equation 2. We have 3x minus 2y equals 4. 3 times 2 minus 2 equals 4. That checks as well. In this section, you will study two ways to solve systems of equations, beginning with the method of substitution. The method of substitution, to use the method of substitution to solve a system of two equations in x and y, perform the following steps. 1. Solve one of the equations for one variable in terms of the other. 2. Substitute the expression found in step 1 into the other equation to obtain an equation in one variable. Okay, well that sounds great. And then 3, solve the equation obtained in step 2. So there it is there. Here is our directive to solve a system of equations by the method of substitution. 4. Back substitute the values obtained in step 3 into the expression obtained in step 1 to find the values of the other variable. 5. Check that each solution satisfies both of the original equations. When using the method of graphing, note that the solution of the system corresponds to the points of intersection of the graphs. The method of graphing. So the graphing method, to use the method of graphing to solve a system of two equations in y, how would we do that? Perform the following steps. 1. Solve both equations for y in terms of x. 2. Use a graphing calculator to graph both equations in the same viewing window. 3. Use the intersect feature or the zoom and trace features of the graphing calculator to approximate the points of intersection of the graphs. 4. Check that each solution satisfies both of the original equations. Okay, so to solve a system of equations, solve the system of equations. Here's our system here. X plus y equals 4 is equation 1. And then x minus y equals 2 would be equation 2. So an algebraic solution for this, begin by solving for y in equation 1. So let's solve for y in equation 1. So when we solve for y in equation 1, we get y equals 4 minus x. Next, substitute this expression 4y into equation 2. So we have y in equation 2. We know what y is here, so we put this up here in equation 2. Solve the resulting single variable equation for x. So when we do that, what it would look like, x minus y equals 2, write equation 2. And then we're going to stick in what we got for y in equation 1. So x minus 4 minus x equals 2. Substitute 4 minus x for y. That's this. And then we get here, we get our negative 1. We distribute that through there. So we get x minus 4 plus x equals 2. And then we get 2x here. We combine these terms, move this over here. And we get 2x minus 4. Well, we're going to move that over there eventually. And we get 2x equals 6, and then x would equal 3. So that would be your basic way of solving a system of equations. Finally, you can solve for y by back substituting x equals 3 into the equation y equals 4 minus x to obtain y equals 4 minus x. This is your revised equation 1. And then we can put x back into that, and we get y equals 4 minus 3, then y equals 1. So that would be a way that you could what they call back substituting. So the solution would be 3, 1. This would be your solution here. And then the graphical solution, begin by solving both equations for y, then use a graphing calculator to graph the equations. So we have y1 equals 4 minus x, and then y2 equals x minus 2 in the same viewing window. So we're going to put these in the same viewing window. Use the intersect feature of the graphs to approximate the point of intersection. When we do that, here is y equals 4 minus x, and then this is x minus 2 here. This would be your point of intersection at 3, 1. And that would be your solution here for these systems of equations. Intersection 3, 1. Let's try one. So solve the system by the method of substitution. Use a graphing calculator to verify your results. So here is our system here. So equation 1, equation 2. Solve for y in equation 1. So we're going to solve for y in equation 1. So then in that situation here, so y equals x. So y equals x. So substitute for y in equation 2. Here is our y here in equation 2. So 5x minus 3x equals 10. Then solve for x. 2x equals 10, x equals 5. Back substitute into equation 1. And we get y equals x equals 5. So in that situation there, our answer is 5, 5 is how our algebraic method here gives us 5, 5 answer. And then you could graph that and get that same solution. Solving a system by substitution. A total of $12,000 is invested in two funds paying 9%, 11% simple interest. The yearly interest is $1,180. How much is invested at each rate? So here's our verbal model. 9% of fund, and then 11% fund equals total investment. So our 9% fund plus 11% fund equals our total interest here. We know what our total interest is here. We know our interest rates, and we have a total here of $12,000. So amount in 9% fund, amount in 9% fund equals X dollars. So we're going to make that. And then the interest for 9% fund equals 0.09 X dollars. The amount in 11% fund would equal Y, and then that would be 0.11 Y. Total investment is $12,000, and then our total interest here is $1,180. So there's things that we do know to help us solve this. So here's our system here. X plus y equals 12,000. We know that. And then here's our interest rates here. That has to equal 1180. So this is the system here. We have equation 1, equation 2. So to begin, it is convenient to multiply each side of equation 2 here by 100. We want to get rid of these decimals. This eliminates the need to work with decimals. So when we do that, we have 9x plus 11y equals 118,000. To solve this system, you can solve for x in equation 1. So up here, we're going to solve for x. So x equals 12,000 minus y. This is a revised equation 2. So next, substitute this expression for x into revised equation 2 and solve the resulting equation for y. So 9x plus 11y equals 118,000 here. And then now we know what x is here, so you can stick this down into here. So we have 9 times 12,000 minus y plus 11y equals 118,000. So here's our substitution in here for x, because we know x equals that. This is our original setup here. This is our revised equation 2 when we multiply through by 100. Okay, so now that we have that, we have 108,000 minus 9y plus 11y equals 118,000. And when we solve for y here, we move this over here, we move this over here, and we get 2y equals 10,000. So y would equal 5,000. So y here equals 5,000. But it's easy to tell now what x will be, right? So finally, back substitute y equals 5,000 to solve for x. When we do that, 12,000 minus y. Right here. So x equals 12,000. X equals 12,000 minus 5,000. And we get x equals 7,000. So now we have a solution here, 7,000, 5,000. And so 7,000 is invested at 9%. So this is our 9% here for x. And then 5,000 is invested at 11% down here for y to yield a yearly interest of 1180. Check this in the original system. So when you check it, it will check. So let's try one here in our guided practice. We have a 2 yearly interest earned from a total of $18,000 invested in 2 funds. Paying a given rate's a simple interest. So, excuse me. Rate 1 is 4%, rate 2 is 6. And then our yearly interest comes out to 1,000. So write and solve a system of equations to find the amount invested at each rate. So we have, see, you are given the yearly interest earned from a total. We have $18,000 fund. This will be invested in 2 funds. Okay, part here and part here. Okay, so what we have here is I went ahead and did this. So this is your setup here. This would be how you would set up this problem. I'm not sure if I provide solutions here, but the setup is everything in these kinds of systems of equations. So here, x plus y equals 18,000. We know that. We can call this x plus y equals 18,000. And then 0.04x plus 0.06y equals 1,000. Here's our system, equation 1, equation 2. And then solve for y in equation 1. So up here in equation 1, y equals 18,000 minus x. Substitute for y in equation 2. So we know what y is, so now we can put this back into equation 2 here. So 0.04x plus 0.06 multiplied by 18,000 minus x equals 1,000. When you multiply this through, we get 0.04x plus 1,080 minus 0.06x equals 1,000. Now, we move this over here and see 0.04. We combine these two together. We get negative 0.02x equals negative 80. So x would equal 4,000. Now, this back substituted into that. So we got a $14,000 amount here. When we subtract x from, or rather, this is our y here. So y equals 18,000 minus 4,000 equals 14,000. So our answer is 4,000, 14,000. So $4,000 at 4% and $14,000 at 6%. Let's go into another one here. We got example 3, substitution 2 solution case. Solve the system of equations. So x squared plus 4x minus y equals 7. This will be equation 1. And then 2x minus y equals negative 1. We'll call this equation 2. Begin by solving for y in equation 2. This is the easiest one here. To obtain y equals 2x plus 1. Solve for y in equation 2. Next, substitute this expression for y into equation 1. So y equals 2x plus 1. We can put this up here in equation 1 and solve for x. So now that we can do that, x squared plus 4x minus y equals 7. Equation 1. And now we substitute for y here. We'll put y in as 2x plus 1, and we'll insert that into our original equation 1, and we get this expression here. And then once we do that, we got this thing here. So we multiply through, and we get x squared plus 4x minus 2x minus 1 equals 7. And then we can combine like terms here. This becomes 2x, and then move this 7 over here. This becomes negative 8. Now we can put these factor two binomials out of this quadratic. We get x plus 4 multiplied by x minus 2. And now we got two solutions here. We get negative 4 as one solution, and then we get positive 2 for another solution. Okay. So we got two possible solutions for x. Are they both correct? Well, back substituting these values of x into revised equation 2 produces y equals 2 times negative 4 plus 1. Does that equal negative 7? It does. And then y equals 2 times 2 plus 1. Does that equal 5? Looks like it does. So the solutions are negative 4, negative 7, and then 2 and 5. So that would be your plots here for your solutions. You can plot that in there. Oh, I do. So here is your parabola here, and then here's your line that goes through your parabola. Solution there, and then a solution up here. Negative 4, 7, and then 2 and 5 is up there. So here's your parabola, and then here is your line. Okay, well, okay, good enough. This is a little zoom in here to see that. Okay, let's try one. So, solve the system by the method of substitution. Use a graphing calculator to verify your results. So here's our system here. So how will we go about solving this thing? Okay, equation 1, equation 2. Solve for y in equation 2. That looks simple. So when we do that, y equals x plus 2. Substitute for y in equation 1. So y equals x plus 2. We'll put that up here. And when we do that, we have x squared minus 2x plus x plus 2 equals 8. We combine like terms. we end up with this here, x squared minus x minus 6. We factor this down into these two binomials. Now we have two solutions, x equals 3, x equals negative 2. And so when x equals 3, y equals 5. And then when x equals negative 2, y equals 0. We put that back into originals up here. So our answer here is 3, 5, and then negative 2, 0. And so you should check that graphing. And as your 7.1, part 1, systems of equations for pre-calculus math. Here is my email if you need a classwork sheet, homework sheet, or any other materials for this course. Thank you.